Hello, stats class. Here is the day you've been waiting for. We are going to start the Megachart today. And we're going to do it in pieces, so this video only covers what's from Chapter 9 and a little bit of Chapter 8. So we're starting with the beginning of the chart side, where we're dealing with one sample test. There were 3 different types that we learned, so we're going to label them as they were a single proportion test, or a single mean, and then at the very end of Chapter 9 we did paired differences. So the first thing that's hard about the inference part of this is deciding which one to do when. We've got proportions versus means, and then sometimes means are as differences. How do you tell which one is which? Well, proportions would happen if you're dealing with percents or parts of a whole. In other words, we're dealing with categorical variables. People are being grouped into categories, and the categories would be yeses and nos, or possibly other things that are more interesting, proportion of people who wear red, or something like that. But it's definitely a proportion, percent, part of a whole, categorical. Single mean is when you're dealing with an average. And because we're dealing with an average, we would be talking about quantitative data. And then matched pairs, basically all of your data would be in pairs already. And that would also be quantitative data. We usually subtract quantitative. We subtract the numbers, which doesn't make sense to do if you have successes and failures. But all 3 of these were in Chapter 9 and not 10, 11, or 12, because all 3 of these have in common that they are one population, one sample, and we are comparing that sample, the statistic from that sample, we're comparing it to a hypothesized value, which of course would be in our null hypothesis. So before we go on, I like to color code these too, and I think I warned you that you might want to have highlighters or colored pencils or something like that. And the color coding will make more sense when I do the other side also, but I'm going to do pink for proportions. And like that. Also, just so this column is all about proportions. I'm going to use blue for means. Don't have a good reason for that. And I'm going to use yellow for paired differences. And then I'm going to use some other colors for the rest of this chart, but we're not going further in this video. So let's remind ourselves of how to do hypotheses. Back in Chapter 9, we first learned to do hypotheses as a p equals or a mu equals for our null hypotheses, or for differences it was a mu d, meaning difference. This one's almost always 0. These 2 you would fill in with a number, and that number has a name, but I'm leaving that name over to the side because I do not want you to ever write P0 as your null hypothesis. I want you to put a number in this spot. Hashtag used to mean number back in the old days, so hopefully you understand that. This number is called mu0, but please don't ever write mu0, write the number that comes from the problem. And then the alternate, as you know, could be a not equals, or it could be a greater than, or it could be a less than, and it would be that same number again. And I'm going to copy that sideways. Or greater than or less than, copy the number, and then this would be mu d does not equal 0, or greater than or less than. Okay? The reason this one's almost always 0 is we're almost always looking to see if there is a difference or not. So the null is there's no difference. The alternate is there is a difference. And then don't forget you have to define what these letters mean. You can't just write p equals and be done. You always put the context, and that's really important, so I put it off to the side. Don't forget to include the context. All right, moving on down. The conditions are almost the same for the 3, as you know. starts with random. You check to see if it's given. And that is the same for this. With the only difference, the difference with the differences, get it? Yeah, the difference with the differences is with this random sample, there are 2 measurements on each subject. And so I'm just going to add that, and that's part of how you tell that it really should be in the matched pairs column and not somewhere else. But other than that, you're looking for a random sample of your subjects. You don't have to write it 3 times unless you want to, because it just keeps continuing over. The second one is normal. And this is way back to the beginning. We're not doing all the NPs and NQs and all of that. We're doing just one of each. So for proportions, you do NP and NQ, except you use the P0 value from your hypothesis. So that P0 ends up down here also. And also NQ0, which of course would be 1 minus P0. Both have to be bigger than 10. That's for proportions. For means, we check either the population or the sample size has to be bigger than 30. So there's a choice here. You could do n is greater than 30. If it is, then you're done. Or the population might be given to you as being normal. That's really rare, so more likely you'd be checking a graph, which would be not too skewed. We're not going to be super picky because there's a 15-30 rule that says between 15 and 30 we cannot be just not picky. And then this is the same over here, except the graph you check is the graph of the differences. So I'm going to add that, but I'm not going to write it all again. So differences is not too skewed. And if you want to write it all again, you can. So you could write n greater than 30, and all of that. Again, the 15-30 rule still applies. But I'm just trying to save you some writing. So the fact that they're the same is kind of comforting. In fact, these two are a lot the same also, which is nice. Calculations. With proportions, we use z. With means, we use t, and that also applies to the differences. So for z, you do the sample minus the hypothesis. The sample in this case is p hat, minus the hypothesized value, which is P0. So that P0 is showing up again. On the bottom, we do square root of PQ over N, except the P and Q are P0 and Q0. In other words, if you have a hypothesis of what the value is, use it as much as possible. Use it in the conditions. You know what? I skipped the first condition. Going back to it in a sec. So use that P0 value here and here if you know it. If you don't know it, that's because you're doing a confidence interval. We'll come back to those. And I forgot the independent condition. That's terrible. Doing it now. So independent is when you check the 10% rule. N has to be less than or equal to 10% of the population size. That is true for all of these, and you don't have to write it 3 times. In fact, that thing about experiments and not bothering to check if it's an experiment, that hardly ever happened here in Chapter 9. It was mostly Chapters 10 and 11 that were experiments, so I'm not going to write it until we get over there. So with these ones, it's almost always a sample, not a randomly assigned treatment, and we're just going to check it with the 10% rule. All right, back to what I was saying before. After you find Z, then you find your p-value, which is the normal CDF sort of thing. And remember, that could be Z and then some big number if you're doing a greater than in your alternate, or it could be a negative 99 comma Z if you're doing a less than, or it could be doubled or not equals. And I'm going to squeeze in the calculator shortcut down here. I didn't leave a lot of room, but the calculator shortcut for a single proportion test is called a one-prop Z-test on the calculator. So especially if you have a TI-83 or 84, you'll need that calculator shortcut. T, when you're doing means, for both of these, you're doing sample minus hypothesis, just like above. So this is x bar minus mu 0, and again, that comes from your null hypothesis. These numbers come from whatever your hypothesis is. On the bottom, we have s over square root of n. And remember, we're using s because we don't know sigma. hardly ever on the AP test seen them give you a sigma, only if they're asking you to calculate a sample size pretty much. Otherwise, they're going to give you S. So we're just not even going to worry about that. We have a DF, degrees of freedom, for a single mean is just n minus 1. Remember, it changed later in the book, but for chapter 9 it was n minus 1. And then you use that to find your p-value with p-CDF of 2,999, or 2 nines is probably enough, CF. Or that's if it's greater than, or it might be a negative 99 and a T and a DF if it's less than, or it might be doubled if it's not equal. So that's kind of familiar. It's the same thing, except instead of normal we're using T. The calculator shortcut here is called a t-test. Isn't that an amazingly short name? It's just your basic t-test. And what's fun is all of this stuff that I said here applies to the differences. I'm not going to write it again, but I will write this a different way, because when it's differences, we do xd star minus 0. It's almost the same thing, and this is sd over square root of x. And all of the df thing and the finding the p-value and the calculator shortcut is all the same, because really this is the same as a single mean. It's just the mean of the differences instead of the mean of something else. And then let's go ahead and do the bottom row, which should be so familiar to you by now. I'm going to scoot over a little bit so you can see that. If p is less than alpha, then we're going to reject the null hypothesis. If p is greater than alpha, or actually, if they give you equal to, then you can write a wishy-washy answer. I just would never do that to you. But if it's greater than alpha, then you're going to say do not reject. By the way, I saw a great t-shirt the other day, reward for people who are listening to me right now. It was the Star Wars theme, and it said, reject or do not reject. There is no accept. You get it, Star Wars fans? Do or do not, there is no try. It's the same thing. So don't accept, you always reject or don't reject. And then we always include the justification and the decision, or not. I guess I could add that. Reject or not. And the context. Alright, and then I'm going to write my sample sentence down below, and I think I'll try to fit it in this space so that it fits on my screen. You can make it longer if you want to. I'm going to say, since p is whatever it is, you put the value of p, and you compare it to alpha, which, by the way, alpha is usually 0.05, and we're really supposed to mention that up in Null Hypothesis, so write yourself a note if you need to. We reject or don't reject the null hypothesis that we're always rejecting the null, and we're possibly concluding that the alternate is true. So you would put your null in context. What does your null say? What does it mean? And then conclude or don't, depending on whether you reject it or not, that the alternate is true. And that would also go in context. So there is the summary of chapter 9. I am going to do a little bit more on this video. I'm going to go to the other side and do a little bit of the how do you decide which one. And I talked about it a little bit in this box up here, but I want to talk about it some more with this beautiful flow chart. So now this thing is big, and I'm going to zoom out for just a minute so you can see it. We're not going to do all of it today. Say thank you. We are going to talk about the part that relates to chapter 9. So the first thing you do when you're looking at data and trying to decide which thing you're supposed to do is you think about, is it averages or percents? That would be proportions, right? Or is it counts, which would be chi-squared, or is it bivariate, would be chapter 12. So this is chapter 11, chapter 12 over here. We're not doing those yet. If it's averages, that's another way of saying it's quantitative data. And if it's percents or proportions, that would be categorical data. You might see the word proportion in the wording of the problem somewhere. And we did both of these in chapters 8 and 9. So then, what you do next, if you have means, and I did rearrange these a little. We did proportions first in the book. I rearranged them so that this would be next to chapter 10 stuff, and I'll tell you why when we get there. But if you do mean, if you're doing means, the next thing is do we know sigma? The answer is almost always no. So usually you're going to answer no. If it happens to be yes, which is very rare, then you would do what's called a Z-test for means. And we have not studied those because they are so unusual. But if you were doing that, you would do the same stuff you would do for T, and you just follow what it says over here. So I'm not going to spend time on this. I'm just going to say hardly ever happens. Usually it's a no, and so that means you'd be doing a T-test for means. Then you ask yourself, how many samples are there? If it's 2 samples, then you're moving into chapter 10 stuff. So I'm going to focus on the 1 sample thing. If you have 1 sample and means, then it's a 1 sample mean situation. And that's the null hypothesis that is mu equals mu 0. So the goal of this flowchart is to match this up with what we said over here about means, which was mu equals mu 0. And I'm going to color code that the same color I did over there, which for me was blue. If you used a different color, please match it up. But the idea is if you're following this flowchart, you could see this and both the fact that it was a 1 sample mean and the fact that this hypothesis is there would tell you that you need to use this column on the chart. That's what the flowchart is all about. And then I left a space at the bottom, which what we're going to do there is write the formula for our confidence interval, because you might also be doing a 1 sample confidence interval for a mean, which should also be blue. And this is the chapter 8 part, because in chapter 8 we learned this confidence interval formula that didn't have a space on the other side. So here's the space I made for it. It is x bar plus or minus t star s over square root of n, and on the calculator it's called a t interval. So if you found yourself in that situation and you needed to do a confidence interval, there's the formula. I just realized I zoomed way out to show you the big picture, and maybe I should zoom back in. There you go. Okay, so 2 samples. We're mostly not going to do this till we get to chapter 10, but I do want to say if you think there's 2 samples but they're not independent, then you really don't have 2 samples, you have 1 sample. No, it's actually 1. And if that's the situation, then you're dealing with paired differences. So I'm purposely going to come back to this when we do chapter 10, coming back. But this one was the paired differences, which in my color coding is yellow. So let's make it be yellow. It could be a different color on yours, I don't know. And we also might be doing down here, it's not quite so obvious because in chapter 8 we didn't talk about this, but we might also be doing a confidence interval for paired differences. That sometimes happens. So let's write the formulas for those. The null hypothesis would be mu g equals 0, and that would help you find the right column on the other side. And then the confidence interval formula is xd bar plus or minus t star times xd over square root of n. On the calculator, it's the same as that one. It's still called a t interval, which is probably why the book authors felt they could skip that in chapter 8. It's almost the same as doing this. It's just we're working with differences. And then the one I haven't talked about yet is the proportions test, which is going to be pink. If you find that you're doing proportions, then you would check to see if it's proportion inference or checking a fit of a sample, which would be chi-squared. We're coming back to that later. But this one right here I want to talk about, and it is a Z-test for proportions. Which we did that on the other side already. If you decide it's this, then you're deciding next how many samples. 2 samples would take you to chapter 10, which we'll do later. 1 sample would take you to chapter 9 or 8, which is the 1 proportion Z-test. And it also might lead you to a 1 proportion confidence interval. And I made those pink on the other side, I think. I'm checking to make sure it goes with the first column of the other side, so whatever color you use for that column, use that color again. The really bright pink that I've got. Alright, and so the null hypothesis would be P equals P0. P equals some number that's called P0. Use that to help you match it to the right column of the table. Or if you're doing a confidence interval, the formula looks like this. P hat plus or minus V star square root P hat Q hat over N. Now remember it was P0 Q0 over N on the other side, on the bottom of the Z formula, and the reason is we have a P0 over here. If you're doing a confidence interval, there is no P0, you don't know what it is, and so we started in Chapter 8 using P hat. So Chapter 8 stuff is going here. And then this on the calculator is called a one proportion Z interval. So these pieces are Chapter 8 stuff, especially this one and this one. And I wanted to come back to those because we didn't do this on the day of Chapter 8. So I'll do a different video for Chapter 10 and a different one for Chapter 11 and so forth, and try to keep them not too terribly long. This one's probably the longest one with 21 minutes. Oh well.